Hey you guys, this is Mr. Sal. It's just a lesson on slope from Unit 3, Lesson 5. Thanks for watching. Don't forget to like and subscribe and comment about the lesson below. The slope of a line describes how steep it is. It describes the change in y values compared to the change in the x values. When a linear relationship is graphed on a line, you call the constant rate of change of the line the slope of the line. Okay, so slope generally has to do more with graphs and I guess really with equations as well. And we've seen, hopefully, from last time what that relationship is, kind of. Slope is generally represented by fractions, which we will talk about here in just a moment. So let's say that we had these three staircases right here. Now if we looked at this, we should be able to determine which of these three would be the steepest. Now we got to be careful with this, especially if it's this kind of stuff is brand new to us. Steepness, I don't know, I guess you could call it incline, right? Or how fast it goes up. So we kind of look at this and we see, for example, the staircase 1, it has 5 inches, it goes up 5 inches and then horizontally 5 inches. Staircase 2 goes up 3 inches and then horizontally 8 inches. And then staircase 3 up 6 inches and then horizontal 4 inches, okay? So what do you guys think? Which of these would be the steepest of all of the steepness? Why then? So that makes an interesting point then. So the 6-inch by 4-inch stair step, okay? Well, what if we just expanded this thing? I gotta give myself some space on this. What if I change this so that it's even longer, like 14 inches? Is it still the steepest? Why not? Well, it changed, right? So now, in comparison to how tall it was, compared to its horizontal length, it's changed, okay? And now, as it turns out, it's still not the most shallow, we could say, but now then it would not be the steepest, all right? So it depends. It depends on the relationship of how tall it is with its horizontal length right here. Now we do have different words for these, which we'll get into in just a moment. However, the slope of a line is like a set of stairs. If we can just focus on these in terms of vertical to horizontalness. You could think about this in a different way. Right? Like which of these would you rather climb? 6 by 4 inch step? A 5 by 5 inch step or a 3 by 8 inch step. Now personally I don't like steepness, so I take the 3 by 8 inch one. Actually my foot wouldn't fit on the 6 inch by 4 inch one. So it would just be uncomfortable anyways, right? I'm just pointing out, right, that you may think about this in different ways, but steepness has to do with that vertical and horizontal change. So this stuff, find the slope of this line, okay? Now, the slopes of those staircases was the comparison of its vertical and horizontal change. So if we did ask you for the slope of these stairs, and I don't know, maybe some of you guys have worked in the construction industry and you would know the slope of these, and that's fine. But if this is brand new to you, just understand that it's always the vertical compared to the horizontal measurements, all right? So for example, staircase 1 would have a slope of 5 compared to the 5 inch length, which would simplify into 1, all right? Now you can make that 1 over 1, that's fine. Staircase number 2, right? We got a vertical length of 3 inches compared to its horizontal length of 8 inches right here. And that's a fraction which we want to keep we want to keep it this way, and it is fully simplified as 3/8. Now, if we found that decimal value, we would find that it is lower than 1, which is why staircase 1 is steeper than staircase 2. And then finally, staircase 3, this one goes up 6 inches, and we're comparing that to 4 inches right here as its horizontal length. And 6/4 could be simplified to 1 1/2. Some guys like that improper fraction, which we do prefer with slope, the improper fractions on these. So 1 1/2 is bigger than 1, which is why it's steeper than staircase 1. And it's also bigger than 3/8, which again is why it is the steepest one. All right, so to find the slope on this, especially on a graph, we need to find 2 points that we can identify the ordered pair for. So I'm looking for where it's going to cross these grid lines. For example, I would be looking for a corner where 2 lines intersect like this. And it could be on the axis as well, which happens from time to time, like in this case right here. Okay. Now let's just identify that point. It's at -5, 0. And let's see, any other points we see on this one? There we go. This one right here at 0, 4. Now you may be wondering, well, where the heck is that stair step that you were promised? It's right here. So you would go up this way and then to the right this way. Okay. Now in general, when we find slope, I always do it from left to right. So I would start at this point, which is to the left, which is the red point. And I go to the point on the right, which is the purple point in this case. And I can see how far up does it go. Well, starting at this point, I went up 1, 2, 3, 4. So I went up 4. That's in the positive direction. 4. And then from there, I went to the right 1, 2, 3, 4, 5. And that's to the right, which is also the positive direction. So I show this as a fraction as 4/5. And that is the slope of that line. So when we're finding these, again, it's more about direction than where it is.
Okay.
Now, if we're always going to the right, and we could see lines like, well, do it a different color, like this one. See, now if I found a point here, and these wouldn't be points that we would use, but I can see from here, I would have to go down, which is in the negative direction, and then to the right, which is in the positive direction, which is what would make this slope negative. So it's like, for example, again, always going from left to right, like if I was standing here, I know I'm fatter than that, sorry. In any case, I would have to go up this slope, and that would make that a positive slope, because you're going up, right? However, if you were, and I would prefer this situation, if you were at the top of this slope, you know, and it was snowy, for example, you could just slide right down it. Down is in the negative direction. So up or down will depend on if it will determine if the slope is positive or negative. So we'll find the slope of this line. Again, it's about identifying ordered pairs that we can confirm their values. So we're not looking for fractions or decimals on these. So for example, I got this one. That again goes through -5, 0. And then this point is at 0, -2. If you wanted to, you could use this one. Okay, so I'm just identifying that we have a third point that we could use at 5, 1, 2, 3, 4, -4. Well, now that we have so many options, we have to choose, and we only need to choose 2 points, not 3. All right, -5, 0, and 0, -2, so I'm going to ignore this garbage right here. Because we only need to focus on any 2 points in order to make our stair step. So on this one, we'll make our stair step like this. Now this is one like we were just talking about. It's going in the downward direction if I go from left to right. And how far did we go down? 1, 2, 2. Now that would be the numerator as -2 over whatever the denominator is to the right, 1, 2, 3, 4, 5. And that is in the positive direction. Now you don't need to write +5 on this thing, of course. We don't usually write numbers with the positive sign, but I guess you could if you wanted to, just not on the homework. And if that fraction could be simplified, we would, but that's as far as we go. Also, we do not like to see decimal values in slope, because then it's hard to determine how far up and down it's going and left or right. Find the slope of this line. Well, this one's different, which is why let's give you guys a minute to see if you can find the slope of this one. Just use the same idea that we've been doing. Got to find the horizontal length and compare it. I did that backwards. You got to find a vertical length and compare it to the horizontal length. All right. So again, we just need to identify any 2 points on the line that we can use to find the slope. So you guys tell me which 2 points you want. All right. So again, there should be some kind of fraction that we'll have. And let's figure out the vertical length of this. Now, you could have chosen any other 2 points, as long as you can identify the coordinates for those. This one, I would say that it goes up 5. Maybe some of you guys are saying down 5. It actually is not going to matter. I have a positive 5. And then how far to the right does this thing go? 0. Now, we got to be careful on this one, too, because we say, what is 5 divided by 0? And, if we're not thinking deep enough, we'd say 0. However, if we plug it into the calculator, it will tell us that it's an error. Well, let's just put it like this. If the calculator can't do it, then only Chuck Norris can. This one is undefined. Undefined, or maybe on the homework, DNE does not exist. So now we can consider this in context, right? Like, how steep are these stairs? Well, no one can define its steepness because I would call that a wall. Now they're going to give us points where we have to find the slope. Enter your answer as an integer or reduced fraction. Okay. So we got to do the same thing, but without the graph. That's kind of a lie, actually. If for some reason you're like, man, I really like that graphing stuff, where'd it go? Just draw one, all right? There we go, I did it. Here's a nice drawn graph, x and y axis, right? And then we got a point at 1, 2, 3, 4. So there's a point right there. And then there's another point at -2, 6 up here. And we can identify those 2 points, draw a line through it. So if we were to look at the stair step on this thing, it looks like it goes down 2 and then to the right 3. You could count it to right, 1, 2, and it goes to the right 1, 2, 3. So the slope then would be -2/3. However, some of you guys hate drawing graphs. And you don't have to use a graph, as it turns out. But we'll look at that in the next example. All right, find the slope of the line that goes through the points. And again, we'll answer as some kind of fraction. So either proper or improper fraction. No mixed numbers on this stuff. So we kind of have to think about what we just did right there on that last problem, which may help us to maybe figure out some kind of formula, right? Well, the thing about the slope is we know it's some kind of fraction. So we can start with some kind of fraction line right here. And if we looked at this, what we did on that last problem, not that we are, but we could, we need to consider the y values first, right? What we're really doing and what we have been doing is finding the distance between the two, okay? Now, distance is always subtraction. It's the difference between the 2 points. And in this case, we have the two values, -9 and 4. We just want to figure out the distance between these two. The x values represent the horizontal length. And since we're looking at how far apart these two are, once again, we're looking at subtraction. So in this case, I would do 15 minus 10. Now we have to be careful with the way these set up also, especially when we're not using a graph, okay? Notice the negative 9 and the 15 in the fraction are in the same position in this subtraction problem, okay? It's the first number for each. And the 4 and 10 are also positioned directly above and below each other, with the y values being above and the x values beneath. And again, we're finding the difference between the two. That always has to be the case. If I had written the 10 underneath the negative 9, those don't correspond. They're not part of the same ordered pair, so I can't set those up in this fraction that way. Same with the 15 and 10. If I had switched those, the 15 and 4 don't go together. So we should be ready to calculate this. All right, so I've set it up like this, but we could have set it up just the other way around, all right? So it's still subtraction because it's the difference between the two values. But if I had done it the other way, so if I did 10 right here, and then I was figuring out the difference between 15, then the only difference would be that, again, the 4 and the 10 correspond together. So they have to be, I don't know, I just say with each other, but above and below each other. We'll look in more detail on that here in a moment. And then the negative 9 and 15, again, are together in the fraction. As it turns out, when we calculate either of these, we get the same answer for both. For example, negative 9 minus 4 is negative 13, and 15 minus 10 is 5. That's negative 13 fifths. Now, I said they're the same. They may not look the same, though, okay? 4 minus negative 9 ends up being 4 plus 9, which is 13. And 10 minus 15 is negative 5. The only difference is where that negative is. And as it turns out, I don't think the homework cares, and I don't care either. So I think that's good news. That is the slope.
Because we're working with slopes, would you put this?
With the mixed numbers. And the homework told us to put this as a fraction, so we want the improper fraction in this case. Inevitably, however, I'll just see this on a test sometimes if you guys really like these mixed numbers for some reason. Which is okay, as long as you don't make a mistake on this step. Sometimes I'll see this, 2 3/5, and so instead of this being circled up here, right, we have this circled. Look, I know it's such a minor mistake, but on a test I have to take the point off. It was negative, right? Nothing I can do. You circled the 1. I can see the work for the negative even. But again, just between those two steps, I just see a lot of mistakes. That's not why I hate them particularly, but that's usually why students hate them. Bam, there it is. This is what you guys wanted. Well, no one really wants this, but in any case, it is the formula for the slope. So this one's set up the same way that we had it before. So this one doesn't show the points, but we could show it here. So you'd have I guess we could say this is point number 1. So the x value and y value would have y1 here and x1 there. Those sub-values just tell us which point it came from. And then you'd have point number 2 over here. But now we're looking at a y2 value and an x2 value. So again, we're finding the difference between these two, or the distance between them, which is why in the formula we have subtraction. Well, then we take the corresponding values, for example, y1 and x1, and then we subtract the corresponding 0.2 values. So this would be y2 and x2, okay? So they have to be directly above and below each other. And the y values are always in the numerator because that's our vertical change, which again will tell us the slope or steepness of the line. Here's the great news though. If you hate all of that stuff, other than everything in the math, but there are other ways to figure out the slope, which we will look at. When you guys see the formula online, sometimes the y2 and, I'm sorry, the 0.2 and the 0.1 values are switched because it doesn't matter, just like we saw in that last example. So let's use the formula on this one. So let's set it up first. All we got to do is replace these values with their respective values. So I'm going to say that this first point here in this list, this is going to be point number 1. So 5 will be y1 and 15 will be x1. And again, I'm just going to go into this formula and replace y1 and x1 with their respective values. And then the second point will be our x2 and y2 values. So y2 is 8, y2, and x2 is the 4. So let's go ahead and replace those two values in the formula. Well, from this point, all we got to do is the actual calculation on this. 5 minus 8 is negative 3. 15 minus 4 is 11. And this is as far as we can simplify this fraction anyways. Just be careful. If there is any simplification necessary, then do it. For example, not just with the numbers, but with the signs as well. It is possible to get a negative in the numerator and denominator, which would change the whole value to a positive value. Well, as promised, I did say that I was going to show a second or a different way, okay? I like this way. I like this way a lot, actually. This is called the rainbow method, and I know we use a lot of rainbows in math. I don't know if they just make us real happy or what, but we do, okay? So here's what I'm going to do, is I'm going to show the fraction over here, because that's all I'll need on this thing. And I'm going to go from the first point here on the left to the point here on the right, and I'm going to connect the y values above and the x values beneath, okay? The reason I do this is because the y values, the difference in the y values will be in the numerator. And the difference in the x values will be in the denominator. Now, this is essentially the same thing, but it kind of skips a step, and I think it's a little bit more pretty. So, see how I have that arrow as well? And the arrows always have to be pointing in the same direction. For me, that's always going to be to the right. Now, just looking at the y values, I went from 5 to negative 1, which means if I was looking at the y-axis, I would have to go down 6. That's the numerator right there. What about the x values? I'm going from 6 to the left, negative 6. That means I would have to go to the left 12, which is the denominator. Now this gives me a fraction, which again I can simplify. Both of these are divisible by 6. You could even say negative 6 to make it positive, 1/2. And that is the slope. That being said, that I like it so much, most students hate it so much, but I let you guys decide. Slope in equations. 3 different types of equations which we'll be using. However, for slope, we're really just looking at standard form and slope-intercept form, so we can kind of ignore this point-slope form for now. So if you guys are copying that down, I wouldn't worry too much about point-slope form yet. We will get to it, but for now, we're not so concerned about it. Now, in standard form, I would recommend using a table just to find the points, the x and y intercepts, because it's really easy. The slope can be found by taking the negative of the a and dividing it by the b, but that's kind of difficult to remember, okay? As it turns out, we can change standard form into slope-intercept form as well. The nice thing about slope-intercept form is that, just like we see up here, slope is always represented with letter m. I don't know why. I don't know, maybe if the Greek word for slope starts with m, or maybe someone just thought it would be hilarious, okay? In any case, the m in this slope-intercept form, let me try to emphasize that a little bit better, m right there, is the same as slope, okay? So, I mean, if I wanted to write this y equals m, but instead of writing m, it's a slope on this thing. And you'd multiply that by x and then plus b. b is the y-intercept, as it turns out. right here. And I didn't have enough space to write intercept. But it does represent the y-intercept. Now, we got to remember, though, the y-intercept is a point where the x value is 0, and the y value is that b value. So when it asks for the y-intercept, we have to show it as a point, like you see here. All right, this one is in slope-intercept form, which is great because, as it turns out, for each linear equation, we're going to identify the slope and the y-intercept. So, just looking back, it was y equals the slope, which was represented by the letter m, multiplied by x, and then we add the b value. So in this one, we can see that the slope, which is the coefficient of x, in this case, is negative 8. The y-intercept is also given to us, but in a slightly different way. Because we got it pointed to the 7 right here, right, so you got 0, but be careful, this isn't positive 7. Again, each term is going to take the operation immediately to its left. This is considered negative 7 right here. Or, if you wanted to, you could show it as plus negative 7 in the form, okay? So this right here is our answer. All right, here's another one. Identify the slope and the y-intercept. Once again, just looking at the form, slope-intercept form, y equals the slope times the x plus the y-intercept. The slope in this case is the coefficient of x, or the number being multiplied by x, which in this case is negative 7. Negative 7 there. And the y-intercept is the constant that's being added to this. But again, don't forget this is a point. It needs to be shown as a ordered pair. So the x value is always 0, and the b value is 2/5. So, and it is possible we could see some fractions on the homework as well. This one looks very different, but it is actually very much the same. So we got y equals mx, slope, times the x, plus b, and hopefully just this setup alone would help us figure this out. The slope, which is m, which is also the coefficient of x, is negative 11 here. Then the y-intercept. It's not shown, but it's there. Okay. Well, we know the x value is 0. We just got to figure out what the corresponding y value is. And we could do that if we just looked at the equation directly. If I replace x in this equation with 0, then what's the corresponding y value? 0. Now, we don't have to do that, though, because it's shown as an equation in slope-intercept form. It's just plus 0 right there. Because if I add 0 to anything, it doesn't actually change the value of the thing. So this would be 0, 0 at the origin. Yeah, I don't know if they did that 7-11 24 stuff on purpose. Some of you guys get it, I guess, though. Slope is 7/11, and the y-intercept is 24. All right, this one's good. This is still in slope-intercept form. Let's look at what slope-intercept form looks like. Now, we have seen this before. The y value is, it's kind of big right here. But it doesn't show an x. So y is not really depending on x in this case, which means that the y-intercept is the same as this value we have up here, negative 957. The question is, what is the coefficient of x in this case? Well, since there's nothing there, we would want to show it as 0. Because remember, if we add or subtract 0 from anything, we get the same value. And this whole value is 0 right here. So the slope in this case is 0. And the y-intercept, again, we're looking at this as negative 957. There we go. Just out of curiosity, if we were to look at this line on a graph, does anyone know what it would look like? with a slope of 0, right? So, yeah, it's a straight horizontal line, which we've seen before, right? So we got to think about this one in relation to that last one as well. If that one, last one was y equals something, and that gave us a horizontal line, this one is x equals something, which would give us a vertical line in this case, all right? So this one is not in slope-intercept form or standard form, for that matter. Since it has no y value, it has no slope. Yeah, so the homework wants you to write D and E. Or, I mean, if you wrote undefined on the test, that'd be fine. So yeah, this line would be vertical right about here. The next question is, right, the y-intercept. Where does this line, if it's straight up and down, where will it ever intersect the y-axis? Never. So again, this is also a D and E for the y-intercept as well. Now be very careful, you can't mix the two up, all right? If it's x equals something, there is no slope, and there is no y-intercept. So again, hopefully the graph helps you out. With the y equals stuff, the slope is 0, and it will have a y-intercept. All right. Well, this is standard form now. And there's a couple ways to do it, is to memorize all the formulas, right? So, right, the y-intercept, for example, because that's what we want, the slope and y-intercept, which is really what made slope-intercept form so great, was it gives us the slope and the y-intercept immediately without really having to calculate anything. However, in this case, well, we may have to do some calculation. So, with the y-intercept, we know the x value is 0. So in the formula, let's write it out. We can find the y-intercept pretty quickly on this thing by just replacing the x value with 0, just like we did in the table in one of the previous lessons there. So 0, again, that really just kind of cancels itself out right here. Yeah, this goes away. And we would have negative 12y equals 48. And to solve this thing, we'd divide both sides by negative 12. And that gives us y equals negative 4. So the y-intercept is at 0, negative 4. The problem here is finding the slope. Okay. So finding the slope, we could find any other value or ordered pair and compare the two with either the rainbow method or the slope formula. Or we could use the equation for slope, which we saw in that first slide. Right, it was negative a over b. And a is the coefficient of x, which in this case is negative 6. I'll use a different color. Negative 6, so I would replace a with negative 6. And the b value is the coefficient of y, which is in this case negative 12. Now it's the opposite of that, which is why I have the negative out here in the front. So it's the negative of negative 6 over negative 12. 3 negatives will give us a negative, and simplifying 6 over 12 would be 1/2. The problem with this is that we have to memorize that formula. So we don't generally like to use this method, although you could. So let's look at a different way in this next problem. All right, either way. So the other method, and yeah, we're just making this up, is to manipulate the equation. Okay. So we've gone over equation manipulation. All we got to do is manipulate it for y. If we do this, if we manipulate this equation for y, then we will have slope-intercept form. Because slope-intercept form is y equals mx plus b. So it's always y equals, just manipulate it for y. So the first thing I would do on this, since I am manipulating it for y, is I don't want the x's with the y's on the same side. So I would subtract 2x from both sides. So I got my 9y, which kind of just drops down. And I've got this, I'm going to show this as, well, before I do that actually, 32 minus 2x. I can't combine those because they're not like terms, just like we would with the manipulation stuff. As it turns out, to make this more like slope-intercept form, I can switch these two around. But remember, this is a negative 2 right here. So I'm going to show this as negative 2x, and that was a positive 32. All right, now this is really close to slope-intercept form. The difference is that the coefficient of y needs to be 1. So I'm going to take all the terms and divide them by 9. Well, that gives me 1y. Y equals negative 2/9 of an x plus 32/9. And I've got my slope now, which is the coefficient of x, and my y-intercept from this 32/9. So that's 0 and 32/9. Make that a little bit better. There we go. And that's it. Parallel and perpendicular lines. Two lines are parallel if we have to have two things happen, all right? The slopes have to be the same, the exact same, and the y-intercepts need to be different. If the y-intercepts are not the same, then you're looking at the same line, which in some mathematics is kind of parallel, but we're not concerned about that. If we're looking for perpendicularity, or whatever the heck you would call that, perpendicular lines, then the slopes have to be opposite reciprocals. Just to review perpendicularness and parallelness, okay? If I had a line and I wanted to see a parallel line, it's got to have, again, kind of the same angle on this, or the same steepness, or, now for us, the same slope. But if this was on a grid, right, we can see that the y-intercepts would have to be different, okay? Again, otherwise you'd just have the same line over and over. And two parallel lines will go on forever and ever in a plane and never touch. A plane is a two-dimensional surface, but whatever. Perpendicular lines intersect. So if this was a line right here, and if I drew this correctly, perpendicular lines create a 90-degree angle with each other, which opposite reciprocals of two equations will give us a perpendicular relationship. So if I were to look at some kind of graph like this, if I had this slope, which is in the negatives, I would have to take its opposite to make it positive, and reciprocating it just kind of, I don't know, inverts the angle. And that would give us 90 degrees, you know, right there. Not that my drawing's perfect, but hopefully you get the idea. These two are only asking for the slopes of the lines that would be parallel and perpendicular to this particular equation. So let's look at this equation and change it into slope-intercept form just so we know what its actual slope is, okay? And again, we are solving this for y, so I'm going to subtract 9x from both sides. Again, I'm going to switch those right away and make this negative 9x with that positive 12, which I can't combine. Then I'll divide everything by 4. So my final slope-intercept form, negative y equals negative 9/4 x plus 3. Now again, we're not so concerned about this plus 3 because we only want the slopes of the parallel and perpendicular lines. The parallel line is going to have the same exact slope, which in this case is negative 9/4. So the parallel line would also have a slope of negative 9/4. The perpendicular line is going to take that negative 9/4 and reciprocate it. So negative 9/4 reciprocated would be negative 4/9. But we also have to take the opposite of that thing. So it would be finally positive 4/9, which we can just write as 4/9. And that would be the slope of the perpendicular line. Now we don't know the y-intercept, we don't really care because they didn't ask for it. Another standard form equation, that's okay. Again, just manipulating this equation for y. Then we'll divide everywhere by 4 on this. So there's the equation of the line that they gave us, and we want the slope of a parallel line for this one, which is again going to be the same as this slope, which is 3/4. But we also want the perpendicular line, which would be the opposite. Since that one's positive, we're going to make the opposite negative and reciprocate it 4/3. And that is the slope of the perpendicular line. Now, it would have been great if they gave these to us in slope-intercept form, but that's not always the case.